Everyone. My name is Andrew Ervin. I am a generative AI manager at Eastman Chemical. I so my educational background actually is in applied math, and I was doing a PhD in math, and I felt at some point about halfway through it like I didn't actually know how to do anything. So I abruptly switched to material science and nuclear engineering. And I got about halfway through that PhD when I realized I wasn't making any money, which seemed to be even worse than not knowing how to do anything. So I came here to Eastman. I started working in operations research, actually building optimization models for production scheduling, figuring out what should you produce, when, and for how long. Network optimization, like how should you think about your supply chain, and a couple other optimization problems like that. So I've worked on machine learning problems. I've largely worked on making PowerPoint presentations. Despite the quality of the one you're about to see, I usually make them better, but I was torn from my usual templates. So yeah, since I've been doing this, I guess probably about a year and a half now, I've been working on generative AI problems here at Eastman. And I'm happy to answer questions. Like I said before, if you're just joining, please just interrupt me, shout it out if you got a question or a comment or a thought. You're not going to hurt my feelings any. So probably around the time ChatGPT started taking off, I had been doing image generation. I thought, well, we've got to get our hands on this. We started building out a few demos and testing some stuff. Found it to be very productive and very exciting and engaging for the organization. So I guess about 10, 11 months ago, they formed a team, and reluctantly I was put in a management position. It's fine. It's not so bad. Uh, and since then, I've been leading a team that's sort of a mix of data scientists, traditional sort of machine learning backgrounds, and software engineers in a new role called AI engineering, which is a buzzword for building stuff with ChatGPT APIs. And so, with that, I'll get into a bit about generative AI, and largely going to be focused on language models. There's other sorts of generative AI, but this is the one that costs all the money and that everyone cares about. So we're going to talk some about what's going on, uh, a little bit about how they work. I'll try not to spend too much time in the boring stuff. Uh, First, because it's not particularly productive, and second, because I don't understand it well enough to get deep in the details. But I do understand enough to have a good feel for how I would think about it as developing a heuristic for how to interact with these tools and how to help other people understand where they're limited and where they're really useful. And I think understanding a bit about how they work is very helpful for that. I'm going to talk about hallucinations, and I'm going to probably give a little of my own color commentary on. As a spoiler, I hate that term, but they are something to think about, and it is a useful thing to understand what is the limitation of something you're working with, and how do you use that, or at least work around it. I'm going to talk to a bit about security. This is something that comes up a lot in discussions here at Eastman. A lot of people are worried about information security around the language models. It's good reason. And so I'm going to talk a little bit about the different ways that you can think about either how you would personally use it or how you would use it in your own organizations. And then I'm going to go into some live demos and actually just show, I think what's the most powerful thing, which is the way that generative AI is useful for data scientists, extending that out to statisticians, operations research, machine learning, anyone who is sort of doing applied math or statistics in their work life. I really actually think this is probably the most powerful place for these tools. I've found them to be incredibly productive for my own development when I am actually doing work, which is diminishing with time. And I've found that, the people I work with and know that are using them are getting just incredible benefits from it. But it's a skill in and of itself, and it doesn't come without some drawbacks. So getting into it, I promise I'm not going to be in big technical things, but this is a screenshot from a very nice website. I'll post a link to it that you can interact with, and that sort of explains high level what the mechanism behind ChatGPT is and how it works. And so it's called a transformer. It's the T in GPT. And high level, what we can think about here is what goes in to a language model. It's a piece of text. So I write something like artificial intelligence is transforming the. I send that to Chat GPT, to the AI, to the real engine in the background that's powering this thing. So build a lot of structure around that, but the core thing I send that text to. So what happens when I send that text? The first thing they do, they take the text and they break it up into chunks. You can think about words. It's a little more than that. It's words and word fragments, and those have like an integer representation that goes to the computer. And so we take each of the words in the sentence so far, and then we learn to attend to the words and their meaning for each other. And so this matrix is you know, the words in the sentence so far by the words in the sentence so far, and the bottom diagonal of that matrix is a weight 0 to 1 of how important that word is for predicting the next word. And that's the upper triangle, which is grayed out. They mask it, they hide it. So you can see, of course, well, art is the same one. But as we go down through the sentence, it learns to pay attention to different pieces. And they call that mechanism attention. There's a very nice paper that was published in 2017. Attention is all you need. First off, fantastic name for a paper. It has over 100,000 citations. It's probably on its way to being second, third most published paper or most cited paper of all time. And so attention is really the core of what's going on here. And if you take a step back from machine learning models and all this stuff that's going on, the name is very appropriate. It's what should I attend to? What should I pay attention to in a sentence? Which words contextualize the next word? That's where we're going as next word. So which words are the important ones and which ones relative to each other are the important ones to predict what comes next? So after we take this and we take the sentence, we take the matrix version of itself, we have some kind of autocorrelative behavior that we're developing across those words. We multiply it again by a vector of those same words, and then we throw it through a big nonlinear model to understand, let's say, a more complex version of what's happening between the words. And what comes out at the end, the important part, is probabilities for the next word. And then we sample from that distribution, and it's softmax Boltzmann function. So you can mess with the temperature and entropize it. You can mess with the temperature and crank it up so that it's very biased towards the most likely thing. And we predict the next word. So you get artificial intelligence transforming the human. The human what? Maybe a period's next. Maybe it's something else. So, okay, well, if we step back from that, what's this like? Well, I could sit at my phone and start typing out a text message, and it'll suggest the next word. And so, in some sense, I could kind of cover my eyes and tap randomly across the three or at the center, or some nice distribution on the three, and spell out a sentence, and then stop at some point. How is that different from this? At some level, it's not. This is just a really expensive version of that. This is $100 million version of that. Microsoft has invested, something like $14 billion right now into the company that makes ChatGPT. Amazon is investing billions of dollars in one of their competitors that is actually people from OpenAI that left. Google has invested untold billions into this and invests more. And so this is an unbelievably expensive autocorrelative model that does autocomplete. And it has its own architecture around it that lets it autocomplete until it's done. But when I talk to it, it feels like a person. Kind of weird person maybe, but it feels real. It feels like something else. And so there's a lot of debate about, is this thing just autocorrect on steroids? Everyone has their own opinion on it. But it's something more powerful than that. And so, a question I would say is, like, let's say it's just autocorrect. But if you can predict the next word, then what can you predict? I mean, everything we do as a species is so contextualized by language. That's the primary tool we have for thinking about the world. And its training is a huge portion of the speech that has been put onto the internet in research papers and books. And so it's a very powerful thing to predict the next word, even if that's all that it's doing. And I think what we really need to think about is how do we think about agency and responsible use and security and accuracy in a world where this is quickly being integrated into decision-making processes, into the tools we use, into things that you don't even know that it's being integrated into. A question I'd ask you to all think about is, how many microphones do you have in your house? How many microphones do you think record you in a given day? Every company that owns one of those microphones that has the ability to can process everything you say through one of these language models. What could they do with that? If it can write code, which it can, and we'll show in a bit, how do we think about how that impacts the software that runs the systems we depend on? If I interact with one of these models, especially the good ones, there's actually some caveats to what I'm getting ready to say, but we interact with these tools, we interact with them through someone else's computer, at least most of the time. It could be in the cloud, it could be in a website application, it could be through a microphone in your vacuum. But however we interact with them, it's through someone else's computer. And so how do you think about information security in the world? And actually, the next thing we're going to talk about, hallucinations. So how do you think about the accuracy of these language models and how they're integrated into our world? So there's also just a question of like how you're accessing it, like a practical question of like, what's the mechanism that you use to go about it? And then just like, what can it do and what can it do? And I probably have the worst answer for that one, which is largely everything and not everything, but I don't know where the boundary is. But there are some things that definitely can't do. So hallucinations. So if you haven't heard the term, it's I would say it's a poorly chosen word for what the observed behavior is, but it's stuck. And so really what we're talking about when we talk about hallucinations, oftentimes is it said something that I found to not be true. And so it's wrong. But truth often is not a black and white thing. And we deal a lot, this crowd, with numbers and data, but a lot of the times the truth is what you make it. And so hallucinations are a really poor term because, well, first, it's anthropomorphizing onto the thing something that really doesn't make sense. And second, because it's not a helpful tool to think about what's happening. I think a more helpful tool would be to think about bias and accuracy. So it is predicting words. It has some very large and complex probability distribution that it samples from to choose what the next word is. But how factually accurate something is a complicated thing. I'll give an example, which is, we have lots of people here at work who use an internal version of this that we've built that's powered largely by the engine that powers ChatGPT. And I've had several conversations with, I don't know, dozens, maybe 100, couple hundred people at this point about how it works, what it can do, what it can't do. And a few people I've explained several times, very detailed, in different levels of technical discussion, what the boundaries of what it's capable of accessing and using are. And in one of our team sites where people ask questions, I saw someone give an explanation of what it could and couldn't do. And it was very confident and it was very wrong. And it was talking about how they can hallucinate. And my response was, well, you're hallucinating. What you're saying isn't true, but it's very confident. It seems true. Sounds good. But that's not the term I would use in English. And it's definitely not the term I would use here. I think a better way to think about this is the language that informs the model that it's trained on, plus the additional training techniques they use, which have actually degraded the factual quality of its answers. But they make people happier. They like the answers better, which is, I guess, more important. Uh, those techniques lead to some things coming out. They lead to some things that can do well, some things that it can't. I asked it, I was like, hey, I need like a good analogy for a hallucination. And it was like, what about a robot that's coloring and sometimes it colors outside the lines? And then I had it generate the image that's on the screen. So I had a very clever analogy. And I think that's actually a pretty good way to think about it. I mean, that's not wrong to color outside the lines, but it's not the intention if that was what was asked. And the biggest challenge that we have with hallucinations or behavior that is, I would say, not aligned to our expectations, maybe a better way for me to think about it. The biggest challenge is that one, it's very eager, and I say that not in the sense that it has will and chooses to do things, but it will often answer a question if asked. If you give it a task, it will provide a response which seems to carry out that task. And very rarely will you get a response back that's, oh, I can't do that. I don't know how to do that. That's outside the limits of what I'm good at. Maybe that's the right behavior, maybe it's not, but that's a reality of working with these tools. Now, there are things that they can't do well. So they're language models. They take words and then they represent them as integers, and then they build this big distribution that tells us what should we choose next. Okay, that's how they work. So what are they not good at? Floating point arithmetic. They're not good at averaging two numbers, averaging 10 numbers. Not good at it. Solving an integral that's a definite integral that I want a number for. Not great at it generally. But they can do integration by parts pretty well. They can do proofs, nice abstract algebra proofs, pretty well. There are some very good proofs published in a deep analysis Microsoft did of the model about a year ago, where it's nothing groundbreaking, but for a model that just predicts the next word, that's a very nice proof. But they can't average three numbers, not reliably. But a challenge we were discussing earlier that comes up is, while they can't reliably take an average of 10 numbers, you'll often get a number back that looks right. And that's dangerous. If you ask it to explain a concept to you, you will get an answer that sounds right. It may or may not be. And that's dangerous. And this close to the real world, this like this approximation of what we feel like interacting with a person is. That's what they're good at. And that can create some of the most dangerous behavior if you put too much trust in a response. And so it's not, I don't say, hey, look, I really think hallucinations aren't a thing. It's that that's not the right way to think about them. I don't know how much trust you should put in a response from a language model. I don't know how much trust you should put in the response from a person. I tend to think about it when I work with it like I'm coaching an intern or a junior employee. Very confident, sometimes very quick, and something that feels clever, not a lot of trust. And so I think that's the more useful way to think about hallucinations. And it's a deeply uncomfortable thing for a lot of people. I can't use this at all because I can't trust it for some people. I don't think that that's a helpful way to think about the world, but everyone has their own way. So how do we move past this? And part of it will be better models. They'll spend $1 billion on one of the next ones, and it'll be much better. A nice analogy someone here at work gave, that I've started using, is right now when you go and you ask a question, the response you get is something like a closed book test, where the AI has all of this information that's been trained into it that it can draw from when it samples the next word and then spits out an answer. And sometimes it's right. The place that most of us who build things are moving to, and this extends to Microsoft and OpenAI and the big companies that ship products you play with. It also is everyone I know who builds with these. This is a term they're familiar with, retrieval augmented generation, so RAG. And really, the way you should think about it is an open book test. And so what we're doing is we're saying, hey, when a question is asked, Where possible, what we want to do is try to find a thing that would lead to uh, a higher probability of getting a better answer. So we want to think about, for a question about, let's say, research papers, or a research paper, or a field of research that has research papers that support it. We might want to try to search first for research papers that are likely to be relevant to the question, and give the text of the research paper to the language model along with the question. And then it can read the paper and respond from it rather than generating its answer on its own. If we're having it write code, maybe we want to have it be able to, in a very contained sandbox, run the code and debug its own output. We may want to say, hey, look, this is a question about something factual, or I want you to do a unit conversion, or I want you to retrieve, some sort of like known property of something. That if I went to Wolfram Alpha, I could get an answer very nicely. I would give it that tool and say, look, this is a Wolfram Alpha question. I take the question that went to the language model, and before I give it to the language model, or in between two language model calls, I send it off to Wolfram Alpha. I get the answer back. I give the answer to the language model. I give it both, and then it can re-represent the contents of that answer, but it can do it in a way that contextualizes. I could have a very complex request, or I could maybe say, hey, explain this like I'm 5 years old, or help me dig deep into this. Help me translate it. And then when you give the translation, help me understand the nuance that could be lost in translation. That's where the language model is strong. Not always, but it's much better. And so by giving it these open book test solutions, we decrease the likelihood of having an answer which is not aligned with our expectations. Longer way of saying we make it hallucinate less. If anyone has any questions, happy to answer. Okay, so one of the other big questions I get a lot about is security. And so what you should pay attention to in this plot, whatever, visual, is the box. And I think of the box here as the world of where my stuff is safe and I keep the information to myself and I don't have to worry about it leaking to the outside world. So if I go to ChatGPT, and I do a lot, even with all the other tools I have, they make a very nice product. And I go and I ask it a question. Okay, well, now that information has been shared with them. And they make the best language models in the world. They're a top tier research house that makes not just great language models, image generation models, and speech to text and text to speech, and reinforcement learning and all sorts of other stuff. So I send the message to ChatGPT, and now it's outside of my world. And now that information is something I have no control over. And so now that I don't have any control over that information, ChatGPT could say, oh, this is a Wolfram Alpha question. I'm going to send this to Wolfram Alpha. It could say, oh, I need to go to the internet. I'm going to call Bing and send it to Bing and get it back. Oh, some person has hooked up a random API that I have a choice to call to. I'm going to send it off to their server where I'm going to save it on their computer, and they're going to have access to Andrew's question. But lots of stuff, I don't care if they do that. It's a good tool. But understanding where that boundary is of where my information is safe is important. And when you use something like ChatGPT or Google or Bing or your vacuum, if it starts talking back to you, or any other voice assistant where you don't have some guarantee of security, it's gone. But that's okay. We have solutions that give us security. And so the middle box here, this is the approach we've largely taken at Eastman, and one that most other companies have followed, at least the ones that are building their own stuff. And so here, what Microsoft and Amazon and Google, who are, of course, the big three cloud providers, and you need cloud computing to serve these things up, because the amount of compute needed to answer a single question is unbelievable. It's really amazing how much energy is required to generate a single word. How much electricity do we need? I'll give an anecdote from one of the big publishers of these language models is Meta. They have an incredible research house. They publish almost everything open source. They write very nice papers. And so they just built one of the best models in the world. and they wrote a fantastic paper about it that explains everything from how they technical challenges they had when they were training it, to how they think about the different pieces of training, how they think about language translation, coding, all sorts of stuff. It's a fantastic paper. And in the paper, there's a section where they talk about the energy consumption needed to train the model. And it's so high that, and of course, it's a lot of parallel computing and super complex orchestration for the hardware side. So when you have parallel computing, for those of you who worked in the space, if you haven't, basically you can imagine one compute thing, a computer that sits and says, okay, I'm going to break up the task and hand it out to everyone else. And everyone's going to go work on their tasks, and then going to bring it back to me, and I'm going to pull it in and tie it together. And so what happens is, depending on who's getting weighted on, different amounts of computer being used. The swings, when everyone had kind of finished up and you're waiting for that one last compute, were so high that they were in the tens of megawatts. They almost shut the power grid down. That's the kind of electricity that's being used to power the training of this. The inference, the asking a question and having it spit something back out, is not nearly that high, but it is very high. It's very expensive. So, okay. So all that said, these three big providers and all the smaller ones too now provide us with a world, what they call a tenant, which is secured and isolated to you. That information has a boundary that isn't permeated, so it doesn't go to Microsoft, it doesn't go back to the people who made the model, and they say, look, we'll rent you the computer to run it, and we'll protect you from us so that we can't see what you're doing here. This is a very safe way to use these things. And you have to build stuff, or you have to pay someone else who built something. But this approach, I talked to dozens of vendors who try to sell Eastman different kinds of AI equipped products, some worthwhile, some not. Most of them build in this way, almost all of them. I mean, they're all using cloud vendors to consume these models, but they're also very focused on this kind of security model, the sort of impermeable boundary of the in world. But what that does is it cuts you off from the tools, and the tools can be very useful. So you have to find a good balance. Now, of course, I can always tie in my own tool and send to the outside world, but now I risk sending my information out. And so you have to think very carefully about what things can go to tools and when is the appropriate time to do it. Okay, so again, the whole point of this is what's secure. So what isn't secure? Going to ChatGPT or Google or anything else, ever. It's just not. But that's okay. You don't always need that security. What is secure? Building inside an isolated box where you run on rented computers and the people have offered you a very nice protection agreement from their multi-trillion-dollar company. Microsoft, I bring this one up because a lot of people may be familiar with this. If you aren't, you will be in the next year or two. I promise it'll come to you. Microsoft has a great model and a great example for what this looks like in a software product where you are safe. So Microsoft offers something called Microsoft M365 Copilot, Microsoft Copilot. I don't know, they change the name of it every few weeks. And what this is ChatGPT built into the products that you use. It's inside Excel, it's inside Word, it's inside of Teams. It'll generate a meeting summary inside of Teams with the push of a button. And it's great in Teams. It's good in Word and Excel, and PowerPoint got D-Team, and those will catch up eventually, I guess. They're not great right now. PowerPoint's better than Excel. Excel is barely usable. So, okay, so it's tied in, but it's also connected to SharePoint. And so, if you have a big organization or you've got a lot of data on your cloud drive, it basically means that it can do this, the open book test answering from the files inside of SharePoint from OneDrive. It can access that and bring that information back, and it can do it in a secure way where it knows, oh, I search as you. I only look at your stuff. And so this still sits within that boundary. Now, they're adding a lot of capability to tie in tool use and go search for other things, and the same kind of questions come up. When is it okay to use tools? Well, it depends on how much you care about information security. Any questions?
Yes, we have a couple comments and questions. One question is, how does Siri compare to ChatGPT?
Yeah, so it's a good question. I would say Siri is well, and the answer to this question is going to change very soon. So Siri from a year ago, Siri from 2 years ago, maybe Siri from today. You can imagine it's the precursor to ChatGPT. It's in a family of tools that are in the precursor, and how it works is, you ask a question, you have something you would like Siri to do, and in the background, a much cruder version of what we were talking about happens, and it has a handful of very specific actions that it's tied to, like open up messages or send a text message or go search the internet. Same would be true for Alexa or any other sort of conversational assistant you've worked with. They've got a set of rules and a set of tools, and it's a very narrow, defined scope of what they can do. When they answer a question, most of the information that's coming back to you is more like the open book test than the closed book test. They aren't truly generating, at least it's a lot my own best estimation, they're definitely not generating at the level that ChatGPT does a response. But what you get for that is something that Apple and Amazon and Google are very happy about, which is something that is less unhinged. It's not going to give you a rambling answer that, like I might, that goes into some sort of weird analogy or spits out something that's completely factually untrue. But it's much less powerful. It's much less flexible. Now, that said, Apple has signed a big agreement with OpenAI, and this thing is going to get built into Siri, and uh, it'll be complicated. Is the answer? They're also building their own large language models, which will run on your phone and not send stuff off to another computer, and it gets murky. Is the short of it. But I think you can think of just sort of simply Siri is the thing that came before, and it's the less powerful, less flexible, but less uncontrolled version of this.
Very good. Thank you.
Yep. Any other questions from chat?
Not right now.
Okay. So, okay. I think everyone gets the power of going and talking to it, and you get a nice recipe for banana bread, or you can ask a quick question. But I would say that's like a fraction of the value. It's not where I spend my time. It's not what anyone on my team is thinking about. Uh, what we're really thinking about is what can we build with it, and what can we build it into that unlocks something we couldn't have done before. And we do the thing that's on the slide quite a bit. And so what that looks like is you take a contract or a document, this example, the Constitution, Declaration of Independence, the I don't know, the recipe book from mom's house, whatever it is. You take a document, and that document has a bunch of information in it. But how do you use that information? Let's say you want to, I don't know, build a machine learning model or do some statistical analysis on the contents of documents. Up until now, generally, the way you would have to do that is have someone write that stuff into a database. Who wrote this document? How many contracts do we have where they're 2 years or longer term? Hope you put it in a database. Doesn't matter that I have the PDF. That's not true anymore. We use these language models as transformation tools. They live inside of some pipeline where we take something that was previously unworkable. It could be an image, it could be an audio file, it could be a piece of text. And we say, we're going to craft a dozen or 100 or 500 questions. And every one of those questions, we send the language model to read it, and we give it a bunch of context. We say, when you read this, I want to know, who wrote it, and this is what it'll look like for someone to have written, and this is what I'm not looking for. And we have it spit out an answer. And then we start structurizing that data. Now you can build models on that. Build a dashboard, nice plot. Manager wants it. You can really start thinking about your unstructured data, your images, your audio, your text in discrete information container blocks. Little tiny pieces of information that can be structured. And these language models are very powerful for this. We've done our own analysis, built, confusion matrices. I've got a poor guy on my team who's reading hundreds of documents and looking at the results of the language model and saying, what was, if we asked, hey, does it talk about this? What were the false positives, false negatives? How do we understand what causes those? Is it just noise? What's the frequency it happens at? What's the type of question that blocks this? What are the constraints that cause it to get blocked? But generally, so far, we've found, 85, 90, 95% accuracy. And for some people, that's a very uncomfortable number, even at 85%. But I can tell you for some of our documents, when humans did it, especially if you had to have them do it a lot for a long time, their accuracy was somewhere around 50, 60%. And our language model solutions were in the 80s and 90s. They're very powerful for this. And this is a use case that I see people talk about a lot less, but this is something that's extremely useful, especially if you are in a data poor environment where there's a lot of stuff that you're like just an inch away from seeing, but a mile away from using. It's very nice. This is a common problem for us. Any question? I'm going to switch to a live demo here in a second, but if anyone has anything, I'd be happy to answer it now.
Don't see anything, but I was going to point out, you mentioned something about image as well. You've talked about language models. You mentioned images, and I've talking to someone today that talked about they've actually had it create images for them to use in PowerPoint presentations. And
yeah, and actually, this image, and I think there was, okay, no, just those two. Yeah, both of these were generated by AI. Probably all of these were as well. This is from someone else's slide, but knowing him, I can assume they were. The Constitution wasn't. That one's a real image. But yeah, they're fantastic for generating images, but maybe more powerfully, they're great for consuming images. So the new language models can take images. Actually, the newest ones can take images, audio, text in, and put image, audio, and text out. So an example of something I've used just like a few days ago, I've been building an application, and really the purpose of the app is to be an interface to quickly sort of run and rerun a pretty simple machine learning model. And so, I bring in some data, I transform the data, I prep it for running the model, then I from the interface let a person label some. When we run a classifier, train those labels, and then it has lots of plots for the business. And so that tool, just on the landing page, as an overview of the classes and the way that the business should be thinking about the classification, they have a very nice PowerPoint presentation where they've sort of done a visual. And I took a screenshot of that PowerPoint and I sent it to the language model and said, hey, I want to embed this in this application I'm building. Can you write the code to create the visuals from this presentation? And it did, and they were a little wonky. And I took a screenshot of the thing that it made, and I said, hey, it looks wrong. Take a look at this, take another look at the original and fix it. And 2 or 3 rounds of that had written, 1,000 lines of code, 500 lines of code that reproduced the visual from the PowerPoint presentation with me not writing a single line. A couple other examples, machine vision, we have in our manufacturing process several areas, less than some companies, but not none, where visual inspection is a part of the process. And so there was one in particular that we're working on right now where we're normal machine learning just going to train a classifier to recognize defects in a product. Well, if you've ever gone through an exercise like this, I've got a guy on my team who has a PhD in industrial engineering, and this is like what he did in his PhD. He spent in his PhD 2 months, 8 hours a day, looking at images and labeling them. We described the type of defect we were looking for. I fed 250 images through it, 100% accuracy in its classification. Now, I wouldn't trust that as a on-the-fly model, but as a labeling tool, it's very useful. Image in and video in and audio in is going to be a very powerful way of using these tools soon.
very good.
Okay, I'm gonna pop over to another window, and what I want to talk about here really is what I think is a major part of the future of data science and analytics, and maybe am I sharing? I can't tell. Yeah, it should be.
You are.
Okay. So this is a real part of the future of using analytics. Now, I would say for Arvid and for others who are deep in their career and extremely experienced, it may be the least useful for them. And for those who have absolutely no experience, they're probably right behind. It's tough to get much value out of it if you don't know how to ask the right questions. But if you're a year or two in, if you're 4 years in, if you're 10 years in, you have a lot of experience, but you still got a lot of learning to do. You're still developing breadth of knowledge about a domain or about the problem or the solution you're using. It's a very powerful tool. And in particular, it's a very powerful tool for people out there. And I know lots of people like this who are strong at analytics, but they're not great programmers. That's not their strength. And through R or jump scripting or through Python, they can hack a solution together, but it's not what they focused on. But we live in a world where programming is becoming an increasingly important part of at least machine learning and optimization. And this is fantastic for those people. So I put together here, this is a toy optimization problem, unlike or not unlike ones that I worked on here. And so this is, two plants, plant one and plant two. They produce three products, A, B, and C. One of them produces all three. One of them produces C and B. We have two customers. They have some demand. They have some cost to ship the stuff to them, and they have a price to pay. And we want to figure out, because here we have less capacity, so we can only produce 1,100 units, and we've got 1,300 or so units of demand. Which things do we not produce? What do we not make? What do I not sell? And so, we have much more complicated optimization problems than this, but this is the core. And so you would typically solve a problem like this with linear programming. That's the standard tool that you would use. And this is kind of easy to set up, but it's a nice example of what it can do. So I gave this to the AI, and here's what came out. Okay, so here, if we want to build an optimization problem, these are what we need. We need decision variables. What can we control? We need an objective function. What are we seeking? We want to maximize our profit generally. So this is our revenue minus our cost. We have constraints. And so here it says the demand, so each customer's demand must be met. We can't have any lost sales. Well, I already know that's not going to work. We have capacity constraints. So how much can a plant make? And then we have some constraints on opportunity cost, which I outlined above. So this said, let's say if we make a certain product on one line, then it takes longer to produce than the others. Okay. So what are we missing? I mean, we may be missing some inventory holding costs, some penalties. What happens if demand isn't met? Product substitution. If they would take a different product, this is a very clever one, actually. This is more surprising than the other two. And so I said, let's go ahead and start coding. And so it says, it writes this Python code here. It builds a model based on what it said. And it says, okay, I'm going to go run through all this stuff, and I'm going to build an optimization model. But it didn't solve successfully. So it wrote a problem. It tried to solve it, and then it couldn't do it. And so it tried again. And then it said, oh, actually, it's infeasible. Why? Well, because it said that we have to meet our demand, and we don't have enough capacity to meet the demand. Okay, so it comes through and it gives us some more information and says, well, what could we do? We could relax the customer demands. We could look at our shipping costs. I don't think that would help. And we could adjust our capacity. Well, if we could adjust our capacity, we probably would. So I said, okay, let's create like a place to dump our lost sales. And so it runs the model, and again, we can come look at the code to vet, do I agree with the way it solved the problem? And I could copy and paste this into my own IDE and run it, and it solves the problem for us. And so we get some results, and then, okay, well, I don't want to look at a table. I'm a manager now, so give me a plot. I hate the colors in this, and I'd complain about that first since I'm a manager and not the quality of the results. And so, okay, so it says, what did it produce? And how much did each customer end up getting? And so it's generating these plots on its own. I didn't tell it what I wanted a plot of, just I wanted some plots. And so it took a stab at something, and I can't fault it for its failures here, but these are reasonable choices of plots it might make. And these plots I could save down. I could also ask for something else. It also gave me this one, which I found to be the most useless. The overall income from production was 100%. I bet it was. So, but But either way, this isn't just link next word, right? This is something real. This is a model. That's something I could take and scale. Okay, that's a place we can start. That's something powerful. And I can come back and ask more questions. I can try to build it out. I can say, how do our missed sales compare to what we produced? What products and customers did we not serve? Okay, so now it starts giving me some results. Tables, more code, more complex solutions. I'm going to hit a wall at some point where it can't solve the question I'm asking. That said, I'm a manager. I don't program all the time, but I don't know, I probably work 20 hours a week after hours and 10 hours a week during the hours writing code still. 95% of the code that I put into something comes out of this. It's very good. You have to know how to wrangle it. You have to know what you're looking for, and you have to know how to troubleshoot it, but it's very good and it's very fast. I can build a whole application, a model, process the data, get the features ready, do analysis, think about how do I want to reduce the number of features. I can think about how do I want to look at them, how do I want to compare them, what should I be thinking about, what are other tools I could try. I can do all of that in a couple of days when I would have spent a few weeks on it before. It's very nice, but you really have to understand how to use it right, because when it starts messing up, you need to know almost the way that I think about it is I'm programming, but instead of using syntax and formal structure for programming, I'm using semantics and intent to program. And so how do I craft the syntactical semantics? What's the form of the meaning that I ask for to best optimize what I do? How do I break problems up into small chunks or tell it to do that? But it's very powerful for this. So I have several other examples, but I won't go through those because I've talked too much. So one thing I want to pull up though is just an example of what the tool use looks like within it that isn't code writing. And so I could say something like, I don't know, what is the melting point of steel? And so hopefully this is a question it sends to Wolfram Alpha. And so it tells me, hey, look, I'm going to send information out to wolframalpha.com and I'm going to allow. Okay, and so now it tells me the melting point of steel, and it gives me a link I can click on as a reference. So the main thing I want you to take away from this is, like, if I asked it, I'll go ask another one. It probably will get this one right. But if it doesn't, okay, actually that's a pretty good start at an answer. So 1370 to 1510. Not a bad answer. I don't know if it's exactly right, but it's not a bad answer. Compare that to what I got here. 2616 based on 57 steel alloys. Okay. But how do I vet if it's right? And when you ask just the language model, you don't, is the answer. The number looked reasonable, decent. Maybe it depends, but I don't know. So I moved through a lot of stuff in 50 minutes. And so I want to open up any questions or comments at this point.
I'm going to go ahead and stop the recording so people will feel more comfortable talking, maybe. If I can find a button to push.